Welcome. You're listening to the IT OT Insider podcast. I'm your host, Willem, and in this special series on industrial data ops, I'm joined by my co author, David, and Andrew Waycott from TwinThread. If you want to hear more about what's shaping the world of industrial data and AI, don't forget to subscribe to this podcast and our blog. Welcome, Andrew.
Hey guys, great to be here.
And welcome, David.
Thank you, Willem. Good to be here as well. And in today's episode, indeed, we are joined by Andrew and Andrew Waycott, the president and co-founder of TwinThread. Andrew has a very long history in OT, and in 2016 he started, co-founded TwinThread to make industrial AI and digital twins accessible for everyone in operations. Andrew, I hope this mini intro is more or less accurate.
Mm-hmm.
All right. So why don't you kick things off by a short introduction of yourself and TwinThread?
Yeah, great. So, as you said, David, I've been working in the world of industrial data and using data optimize industrial factories and field deployed equipment my whole career, over 30 years at this point. Started my career in the pulp and paper industry, both in Canada and in Belgium. From there, I joined what was a very small company at the time called Mountain Systems. We developed a MES system at the time called Prophecy, later called Prophecy Plant Applications after we were acquired by GE. During that time, we also built Historian, which was also acquired by GE and is still today the Prophecy Historian product that they market and sell. From there, I founded a industrial consulting optimization company called SlimSoft, which eventually merged into a company we called Factora. And shortly after exiting that company, I rejoined the band, if you will, with the founders of Mountain Systems. Again, my colleagues Eric Udston and Todd Nettle, to form TwinThread. And really, TwinThread is all about making industrial data accessible to the non-technical engineers and subject matter experts in manufacturing, and allowing those people to really deliver and solve problems in their industrial companies without having to become scientists and know all of those intricacies of that, but still empower them to use their expertise, which is how to make the stuff that they're making to actually solve these problems in industry.
Yeah, we're gonna talk about that in this conversation. Is there still a big gap between making data? I would say being a data-driven organization versus just, I would say, going with the flow from problem to problem each and every day. What's your take?
For sure. I mean, the market in general, I think when I started my career, it was obviously extremely rare back then for companies to have any sort of data strategy at all, and really it was fighting fires day to day. But frankly, still today, I would say the majority of companies that I visit don't have a cohesive data strategy, and it really is, how do I solve my next problem most of the time? So, things have changed, of course, and there's lots of momentum towards these kind of bigger data platform strategies and things of that nature. But it's still a little bit the Wild West out there. Yeah.
Well, more things to do for us, I guess. We'll certainly come back to data strategy, but before we do so, as our readers and listeners know, we have this thing called an industrial data platform capability map.
Yeah.
Not going into the details right now because we have a first episode in this series where we explain the map in detail, myself and Willem. But I would say, first of all, how do you perceive this map? Where do you position TwinThread? Can you explain a little bit, I would say, the different components of your offering to our listeners and those who are only listening? Also go to the blog, to the article where we will also make this visible.
Yeah. So first of all, it really hits home what you guys have put together. I think you're really covering well the various components of this space. So it's funny, in your blog about reducing your data platform, you make a comment about how all vendors are going to say they do everything, and I'm no exception. I'm going to say that.
Okay, all right. No, but yeah, it's we thought so.
Yeah. But I'm gonna put a big caveat on that, which is you also said in that same blog that you're not endorsing any company choosing just one piece of software to solve this problem, and we believe that fully. So while we do cover all the aspects of that, and I'll get into some of those details here in a second, I do so in a way that is intended to help solve that area as opposed to closed system in that area, right? Okay. So starting at the beginning, connectivity, we do have edge connectors for a very broad set of industrial data sources. The classic historians, OPC, MES systems, databases, also more cloud systems like IoT connections and the like, MQTT, of course. So we have a really rich set of ingest capabilities into our platform. From there, we kind of bring in and organize that data into digital twins. So that's your context and data management layer. So we have a rich digital twin, which I would say follows largely your asset data model structure, but we also incorporate and give access to data around quality and maintenance and production, et cetera, within that same digital twin infrastructure. We use our thread engine, which is our logic engine in our platform, in a whole bunch of different ways. The first place we use it is here for both allowing our customers to add context to the data that's coming in, the raw time series data, for example, but also we use it as a form of cleaning and organizing of that data, which falls into your data quality section. Of course, within a digital twin platform, with all that context, we have to be able to store that information. So we are, in essence, a cloud historian within our solution as well. That being said, I don't advocate customers ripping out their historians on-prem and things like that. We view our solution as augmenting that and giving that additional ability to organize and provide context from our platform. But in fact, we are a historian and storage layer. And then, of course, we have to have a dashboard and visualization tools and things. Trending and whatnot are all part of our solution. Again, I view that, and we'll get into, I skipped analytics. I'll come back to that in a second, but I view our visualization layer as what is needed in order for that subject matter expert I was referring to earlier to be able to operationalize the problems they're trying to solve. And so we're not trying to be a comprehensive dashboarding tool for manufacturing. What we're trying to do is enable people to solve problems.
Yeah.
Be able to see data in order to do that. Data sharing, again, we do. You talk a lot about the bronze, silver, gold type methodology. As part of our solution, we actually provide data sets that we call them curated data sets, where we take data that we use the context we have to pre-filter, pre-organize, and aggregate data into easily consumable data sets for tools like Power BI or any other BI layer tool. And we can either present them directly to those tools like Power BI, or we can drop them into like a drop zone for
Yeah.
Databricks, Snowflake, et cetera, to pick up. In essence, by doing so, we can essentially curate and provide that gold layer data for take forward from there. And I skipped analytics, which frankly is the core of TwinThread. All about what we do is about presenting use cases for manufacturers to be able to identify, optimize, and solve problems in their manufacturing facility using AI as a core enabler of that, and drive that through to actually operationalize solutions for the manufacturer running in the plant. And of course, I'm sure we'll talk more about that as we go along here.
Wow. It's
So
a
yeah,
lot.
you
That's a lot.
covered every field.
Yeah.
Yeah, yeah, you did. You did.
As
Willem,
an example with connectivity, I have no aspirations to be everything for everybody. I'm sure use tools like, for example, HiByte and Litmus and those types of technology to bring data in to the overall ecosystem. And if they do, that's great for us. We'll just use that data and those streams as well. So we're not closing the anything, but we do have enough pieces that subject matter expert can get started without having to build an entire sort of architecture themselves before they can even solve a problem.
Okay. Well, talking about solving problems, I think you also brought like a use case, maybe to show a little bit and make it a bit more concrete.
Yeah, I
So
did.
tell me more.
To tell a story about one of our customers, Hills Pet Food. Hills is owned by Colgate. We work closely with both Hills and Colgate. But with Hills specifically, the story I wanted to tell is about our work in their dry kibble dog food or cat food plants. So in their facility, we have implemented all those pieces that I've just talked about, connecting to their largely Aviva Wonderware type infrastructure, MES, data historian, etc., pulling in data from hundreds and hundreds of data points per line. And then using that data, we targeted optimizing the quality of their process. And so, with dog food, you need to have the right moisture level, the right fat level, the right protein level, etc. I won't get into details of the manufacturing process, but what we actually have been able to do is using our platform and our perfect quality module, which is essentially a very wizard-based walkthrough of how to configure and, as I said, operationalize, very importantly, the process of optimizing quality. We've been able to predict the quality of their food at the end of the line, but with the timeliness of them being able to make changes at the beginning of their, so as to never produce a bad batch of product. And even more importantly, optimize those quality parameters such that we can target both the perfect location within spec to hit at the best profitability / yield point for that process. And so we've done that at scale now across every single line Hills has around the world. I believe it's like 18-ish production facility lines globally. And it's a fully closed loop solution. So not only are we analyzing and presenting information about what is driving all this type of variance in how their quality is happening, we're pushing those results back down to the control system so that their process can auto adjust itself to always hit that perfect quality. Obviously, that means a very consistent product. Another knock-on benefit of that, though, is as we've looked back over the past years with challenges around hiring staff for manufacturing facilities, etc., as they've seen post-COVID, a dramatic reduction in the average tenure of an operator, we've actually driven an increase in quality because our product is essentially embedding all of those black magic secrets that were in operators' pockets into our solution. And so we're actually reinforcing daily, hourly, by the minute, best practices within their operations.
Okay. You were mentioning closed loop. I don't think we've seen that many examples in the life of closed loop, or at least it's not common, I'd say. And so you seem like somebody who has a lot of experience with automation systems, implementing MESs and systems like that.
Mhm.
How do you go about implementing this in a closed loop system?
Yeah, so you're right. I think I'm proud to say I think we're the first company that has been able to, at that scale, do a closed loop AI empowered quality solution in a food industry. So that's something we're very proud of. And this was a number of years ago that we completed that work. So it's been true for a while now. It's I think a lot of people spend a lot of time focused on edge when they start thinking about closed loop and speed and millisecond response times and things like that. But in most industries, if you actually take a step back and look at how operators control their plants, they're not sitting in front of a screen with their finger over the enter button to do something, right? They're walking up and down the line. They're looking at different screens. Realistically speaking, most operations are making it maybe a couple times an hour, right? And so closed loop doesn't have to be millisecond response. Closed loop, I would argue, in most process industries shouldn't be millisecond response because there's an inertia inside of a line that you need to see the results of what you've done before you can do something else. So it's really not that hard, frankly, to push down recommendations every X minute to a control system. Now, being careful, of course, where you're pushing down to recommendation registers in a PLC, for example, and the logic in that PLC, guardrails in that PLC to make sure not something crazy isn't being done. And if those guardrails are passed, auto accepting those recommendations into the set points. But of course, having a switch so operators can flip the switch depending on, if something is going wrong, they can take back control and do it the way, they always did. But doing that, again, conceptually is not hard. It is also much easier for operators to accept that because they're still in control. They can make decisions about when to accept it or not accept it if need be. And it follows the paradigm they're used to. So from an acceptance and cultural transformation perspective, it also is a significant improvement.
Okay. Yeah, I think technically it's never really the issue. It's more like everything that surrounds it,
Yeah.
like the people on the shop floor, how you're programming your PLCs, even because it's not just some cloud solution that's going to deliver everything. You also need close collaboration with
Absolutely.
the shop floor at that moment to make closed loop happen.
Yeah,
So
absolutely.
they need to be on board with this.
Yeah. One thing that we have, I'll say that we have learned, we used to, in our early days of kind of dabbling and touching closed loop, we used to start our conversations with customers of saying, don't worry, we'll get there someday. This isn't something we'll do tomorrow, because it was scary, and it's still scary for most people in manufacturing. What we've learned is the best thing to do is to start the project thinking about that. And as I said, if you think of that analogy of the registers and set point registers and an accept button, like there's no reason why you can't do that even on a pilot project, because somebody's physically pushing a button to do it, right? And as soon as you've done that from day one, you're set up for that pilot project to be successful and evolve into a fully closed loop solution. Why add steps of, oh, are we ready? Are we ready? You're not introducing risk by doing that initial kind of integration almost right away.
But that's probably okay. So the closed loop thing is something indeed. It's not too common, but I also want to link that back to an overall strategy. You talked about data strategy.
Mm-hmm.
What I see happening quite a lot is very ad hoc projects. Like, we're gonna try something over there. We're gonna use this tool. We're gonna play around with whatever.
Yeah.
And if you're really, that's, I would say, that ad hoc in your approach, then first of all, it is very hard to do something clever with data, let alone AI. You somehow need to build that. Someone needs to, I would say, sponsor that strategy. So what are what are good strategies from your perspective? What makes or breaks a data strategy?
Yeah. So this I guess may be an area where we differ a little bit from the, I guess, the common thoughts in the market today. Our platform, really at its core, what we're trying to do is accelerate through, get the data in the cloud and get to solve problems as fast as possible, right? Like, there's been a lot of money and time spent on this theory that if we can just get the data in the cloud, miracles will happen, right? And very little time has been spent on, okay, how do we actually drive value, right? And so TwinThread is all about being able to start small and go fast and solve problems and get value all along the way. But because our platform is as broad as I described earlier, you know, you're not doing a little pilot project in a corner and then realizing that can't scale. The platform's to scale from day one, and but that doesn't mean you have to take on everything at once. It means you're you're following within the guardrails that we provide, a path that will get you to scale, but you can start really small. And personally, I think that's the way to go. You're you and I guess the big challenge, and I'm not sure if this is for right now, but one thing that I see as a really big challenge in the market right now that I hope is going to change over the next few years is, as all of the different companies out there, the end user companies, are building their own data lakes. Essentially, what they're snowflake, and I don't mean the company, I mean the thing that falls from the sky, a snowflake of data structures and standards. There's essentially, we're going from a world where
Yeah,
there was one standard, a historic
yeah,
value, right, to 1,000 different or 10,000 different ways of saving that data. And that disparity is causing it to be really hard to take advantage of the learnings of others.
yeah.
And so
The,
we're in a situation where hopefully we're providing enough of that
yeah.
to get started easily.
Yeah, indeed, and you're absolutely right. And I had the discussion also a couple of times. Well, actually, I have this discussion multiple times a week. Is what structure do we follow? How do we get our data in whatever cloud we've decided to use?
Mm-hmm.
But everybody is. We are today again in a scenario where everything is again bespoke.
Yeah.
Everyone builds their own thing
Yeah.
because there is indeed no default standard.
That's right. It's really, frankly, I'm a little worried about it. And if just look at TwinThread, right? As I talked about at the beginning of the story here, we've got all these out of the box connectors to every historian imaginable and things like that. Well, why can I do that? It's because there's a standard there. It's easy for me to connect to historians because there's a paradigm that is relatively strong, right? If you go look at how that same concept of storing time series data is being done in Databricks, for example, and this isn't a diss on Databricks, it's just using that Databricks tool. I could go to 20 different companies and there will be 20 different ways of storing that data at the silver layer, right? And obviously at the gold layer it's going to be different, but that's okay, I guess. But even at the silver layer, have clean data that's ready for use. That clean data looks different at every single company you go to.
Yeah, no, for sure. It's a big challenge, and I really hope that I would say in the years to come, we again go to some of those. I would say, the standard way of working where just to be able to scale, because that's the big problem. The big problem is not really everybody building their own thing. Well, that also is very costly, obviously,
Yeah.
but it's hard to maintain, and it's even more difficult to scale.
Yeah.
And from a supplier point of view, every time you go somewhere, you're faced with a new, I would say, with a new data problem to solve.
Exactly. Yeah.
Yeah.
Talking about scalability, because that's also one of the things, doing a little bit of research about you guys, I think one of the selling points you mentioned was scalability.
Mm-hmm.
Now, I would be interested to know from you, like, what do you mean with scalability? I mean, there's technical, but I'm sure there's other aspects. Let's just start with that. Like, how do you define scalability?
Yeah. Well, I mean, I think, like you said, there's some technical ones and there's also organizational ones, I guess, right? So just speaking technically for a minute, we have over 1 million digital twins running in our platform today, 50 million sensors, and over 2 million AI models running. So that's technical scale. And some of our customers, it's very common. I'll get questions, like my first company I worked at, the pulp mill here in Canada, we had 100,000 tags in our Pi system, and that was like mind blowing. But it's nothing compared to the amount of data that is out there today. And so we deal with the scale of data and devices and all that complexity really well. The AI models one is actually really interesting. People don't really think when they're doing those pilot projects at the beginning that, like, managing an AI model and keeping it healthy is huge post data science project, like retraining and ensuring that it's, the latest is deployed everywhere, et cetera. And so within our platform, we actually automate a lot of that as well, the retraining process and the health of the models. And the other thing that's really key to scale is if you do have a scenario where you have a fleet of pieces of equipment that are the same, you want to be able to manage that model at the fleet level, not down at each individual device level. But what's interesting and what we've done, I think relatively uniquely, is what's the reality in most manufacturing facilities is you may have the exact same motor or dog food line in your factory. You may have 5 lines that are identical machines, but they actually aren't identical anymore, right? And so the idea of building one model and having it run everywhere is really not that practical. So what we've done is we've designed a solution which we call the model factory, which allows us to automate the process of training each of those lines with data from themselves uniquely while managing it at the macro level. So that means that each line essentially has its own hyper-personalized model for each line and each product within each line, so that the modeling is scalable across an entire organization and automated so that one person can be managing an entire corporation's worth of industrial data. So there's the technical part. Organizationally, I think it comes back to that operationalization comment I made earlier, like designing a solution that, and our kind of out-of-the-box solutions are designed such that it's walking you all the way from the data science of figuring out what data I need, et cetera, all the way through to how do I get this in front of operators and close the loop. And we believe really strongly that unless you start your project with that sort of end goal in mind of closing the loop, you can't scale globally with a solution, and actually deliver the value you're hoping to.
Yeah. Could you go a bit deeper on the last point? Like, why is that closed loop part so essential to achieve the scalability that you're looking for? Well, what happens if you don't have it?
I mean, how many projects have you seen in your life, or I can certainly say in my life that I've seen, where you build a dashboard or you provide some level of insight, or even a project that has nothing to do with IT, that you design a new black belt Six Sigma project around X, Y, and Z, and you leave the project and you're so successful and everybody's happy. Then you go back and visit that same company 3 years later, and nobody's doing anything related to what you did anymore, right? It's become shelfware or whatever. And so that I think that's my point. Like you need to have something that actually embeds into the daily work practice of the team, in order to ensure that that's actually going to continue for the long term, and the value is going to realize, because you don't realize value from a AI machine learning project on day one. You realize it at the end of the year when you look at your financial statements and you see additional profit at the end of the year, right? And that only happens with continued use of the solution for the long term.
But it's interesting because it's absolutely start small, think big, but with a non-optional think big, where you go like, we need to be. I would say we need to reach that certain point. In your case, we need to be able to automatically have these AI models run in closed loop. We're taking steps towards it, but the end goal is still clear. And
Yeah.
I like that a lot, because it's a bolder statement than
Right.
saying we're happy if we see the trends.
Yeah.
I would even put it like slightly differently. I see a lot of analogy with what's happening for since more than a decade in DevOps, where it's not just about the practice of deploying, bringing operations and development together. It's also about automating as much as possible, because that frees up capacity. It
Right.
takes stuff off your mind and it makes it repeatable.
Yeah.
So I feel something in the same direction. If you automate it
Yeah.
through closed loop, your model is there, it's taken care of. You don't need to work on change management, tracking, asking people to do it all the time. It's there.
Yeah. Now, I am going to hedge my bets a little bit here and say every industry isn't going to be able to do that, right?
No.
There are some
No.
practical. So closed loop in some industries may be actually a screen that has the recommended set points on it, and a work process for operators to do the final decision making of implementing that in closed loop. That may be the best you can do in a certain industry, but it's still having that mindset of, we're getting to an operationalized thing that's going to actually affect the shop floor, and how it runs. That's what's actually going to realize value, right?
Maybe another totally different question. We do some work around IT/OT convergence, collaboration models, etc. We talk about the simple fact that you need technical cooperation and organizational cooperation. So
Mm-hmm.
suppose you go to a customer and you're pitching TwinThread. What are red flags for you when you're talking to a customer and you hear something? What are the red flags where you go like, yeah, chances that we are going to do a successful project over here are going to be, I would say, very, very low, to say the least.
Right. Yeah. I mean, I think in our case, automation and some relative sophistication in the controls layer is sort of a
Mm-hmm.
key requirement, right?
Yeah.
We do often still, as I said in my intro, we still often will talk to customers that are taking their center lines and writing them on a piece of paper, and things like that, and um, they may be excellent candidates, but they require a couple of steps of transformation to happen at the beginning of the project. And so when I'm in situations like that, it's not so much that company is a red flag long term, but they're somebody that we will need to pull in, a partner to work through that initial sort of automation
Mm-hmm.
layer work prior to them being a ideal candidate for leveraging our platform. Yeah.
So that I would say that's on the automation side of things.
Mhm.
Would you also do you also see differences in, I would say, overall maturity related to data, having champions available about IT/OT collaboration, that type of things?
Yeah, I would say so. Obviously the dream scenario is ITOT, gets along and loves each other, and that I've seen that once or twice in my career. But the the reality is I do think you need to have champions within the organization, and ideally quite senior champions within the
Yeah.
organization to certainly to get to scale. Even though I talked about our, what we see as the keys to a successful value being, scale and operationalization. Um, of course, we do very often do pilots with companies that start quite small, and where they have maybe one guy, one team and one plant that is forward thinking, and quite frankly, those often struggle if the cultural um, senior vision differs from that person's vision. So
Yeah.
to get from that first line to all the lines, or all the lines to the next plant, you really do need that sort of kind of more senior buy-in to the importance of the strategy of data and industrial AI and things like that in order for that to be successful. The good news is I think that's becoming more and more common.
Mm.
If I compare to 9 years ago when we started, it's a very different world today in that regard. Yeah.
Well, maybe one final question, given that you have quite a longer experience in the field, where do you see, or what are, according to you, the roadblocks when it comes to digitalization initiatives, specifically in manufacturing? Where do you see like the problem is now, and if you could get this unstuck, we would make a next wave happen?
I think honestly, I already let the cat out of the bag on this one a bit. My comments about the lack of standard for landing data in data lakes. I really see that as um, a major impeditiveness to us being able to move forward as an industry, right? Like, just again, if I think back to where I started my software career with Mountain Systems, right? Like, we built a MES system on top of Pi. That's what we started doing. And it really started out being a quality system on top of Pi. And then we grew it to a full MES. That would be very hard to do today, to build a MES system on top of people's cloud time series data stores. Right? It's just, think about that. And that I believe is the core blocker. And what we need as an industry is to maybe as a silly example here, like, if we think about MQTT and the UNS world, right? MQTT is central to that. Well, MQTT has no standard,
No.
right?
No.
Any format you want, it can look whatever. Sparkplug B takes that technology and it layers a standard on it so that you can now interop between all these different systems, right? That's why all the UNS stuff is going on, et cetera. That's why, right? Now, what's the equivalent for stored data in the cloud?
No.
There is not one. And until there is one, it's going to be very hard for companies to truly realize the value of this. If we get our data in the cloud, we're going to see miracles happen. And unless they just build everything themselves from scratch, which of course some companies are doing and being very successful of, but the ability of that to be accessible to the medium and small manufacturer, that only happens when standards truly become something that we can count on.
Absolutely, it's absolutely, and it's not just about I would say the cost of building this thing yourself, which I think everybody understands. Well, maybe everybody understands that there is a cost. Most people, I think, tend to underestimate that cost.
All people tend to
Big time.
underestimate costs.
Probably all people. But the interesting thing is that what you actually want to achieve is you want to make it so easy for people to experiment, to make changes, to grow. So you want to reduce that cost of experimentation to the lowest possible either time or monetary investment. So people across the enterprise can just go like, oh, here's an idea, oh, it works, or it doesn't work, and then I think that's the big problem, the big outcome of being I would say in such a bespoke mode.
Right. Exactly. And really that is in this world where we don't have standards, I guess, that is what we've tried to help with, right? So that's why if you look at our website and our offers, we talk about perfect quality, perfect uptime, perfect batch, energy optimization. These aren't just ideas. These are actual, like, in many cases, wizard-based things that a engineer in a factory that gets an idea, like you just said, David, can actually go and solve, right, themselves and see if it'll work on their line. And if it does work on their line, they can try it on the next line and the next line, and it'll expand from there. And that's why we've done that, and hopefully taking the complexity of all of this stuff in these blockers and things that we've been talking about away in the reality that we live in this at this time with the industrial data platforms.
Perfect. I think that's a wrap for this episode. So well, absolutely. In this episode of the ITOT Insider podcast, we again explored how to make industrial data, and in this case also AI, work for us. Very big thank you, Andrew, for taking part and sharing your insights, and to you, our listeners, for tuning in. If you enjoyed the conversation, don't forget to subscribe at itotinsider.com and leave a rating, because it absolutely helps. And see you next time for more insights in bridging IT and OT. And until then, take care. Bye-bye.